Hello student, today we are going to perform our last experiment of VLSI design. Okay, the subject is lightly introduced in our syllabus and subject code is EC701 VLSI design. The last experiment in this series is program of D type flip-flop. You all are already know about D type flip-flop. What is a flip-flop? Flip-flop is a condition where data stores in your buffer stage. Okay, and the condition of that buffer will decided by the bit given to the reset or your clock pulse. Clock is high, low, reset always be high. When you press reset button, it means you are providing the command to reset high. High signal you are providing, that's why it resets. It resets. And what is the meaning of reset? Meaning of reset means the condition prevailed as previous where all input is 0. What is the reset mean? When you press reset button, it means you are providing a 1 signal, a high signal plus 5 volt supply in spite of 0 volt supply. And what does that mean? You are going to prevail your previous condition, your 0 input condition. Okay, so as you know about library, we include all library, and important part is our entity. Entity means IC which you are going to construct. So here is, as I have told you, I already discussed here, clock. Clock is the pulse which changes the position from present to the new position, present to the future position. As you press the clock pulse, which is a trigger pulse, is high and changes the position from present to the new. Okay, reset, as I have told you, reset means a switch, a pulse switch. When you press, it provide a higher pulse to the our buffer. Okay, then A is input and B is our output. So in this manner we are going to employ here 3 input and single one is output, which is B. Here output strictly will follow the input. If B is 1, that means before the providing clock, the A is 1. That's why B become 1. Okay, and vice versa. Both may be happened. So this is our program. And what is the code? The code is very simple. You can understand the code here. Process begin, which is common. Process start with clock and reset. Here, if reset is 1, it means in any condition I press pulse switch, then reset would 1. And in this mode, strictly output, which is B, would be 0. Irrespective of that, what was our previous condition of our buffer, of our flip-flop, the data will reset and all output becomes 0. And if it is not happened, it means if you are not pressing reset in all that condition, when clock event occur, it means when you are providing clock, when reset is 0 and you are providing clock, then B follow the A. A may be 0 or 1. Okay, so this is the process. In nutshell, what I would like to say here, the reset is high, then B output irrespective of condition of input is low. But when reset is low, your B strictly follow A at coming event of clock. Okay, so this is my D type flip flop. Okay, now let's switch over to our Xilinx software. It is my Xilinx software, and you can see here, as you know how to excuse me, as you know how to construct the program. In my previous video, in my previous lecture, I have already told you. So there is no, I don't think there is any need to provide you this information. Okay, we just skip over that section and coming over the main issue. The clock which is input, reset again input, A is input and B is my output. Okay, so the program as I have described you in your PDF document, now as it is I have copy here. After then I will make any change for suppose this column and save to run my check syntax. After double clicking my check syntax, then my program process check syntax completed successfully. Okay, now let's come over to the simulation part. Over simulation, I will already run this simulation, and when I check syntax of this behavioral, it shows the checked syntax is successful. Now when I double click or right click and click the run, then the program will, the output will looks like that. Okay, so in this you can see when reset is 1, when reset is 1, either clock you are providing or not providing, your output will be 0. Okay, I am running this program again. As you can see, as I run the program, my reset is 1 and my output, which is B, is my low. Again, when I changes the condition, when you change the reset and for constantly the 0 here, applying this, then by running the program, you can see the position of B strictly follow the input A. It means the reset is predominant over all the program. When you change the clock, the mode of clock, which is from 0 to 1, okay, and apply here, so what you find then again change the value of A, which is 1, and apply here and run the program. What you find as clock arrives, the B output follow the input. So in this manner, you can see here, you can learn here that my D type flip-flop is working very well over the software. So this is my last experiment of this VLSI design software. I hope you enjoy of this video. Okay, so thank you for that. Thank you.